Did my SCJP certification in December 2009, and after that, as you can see, I did my SCWCD certification also last year. I have a training experience of over 3 years with Whizlabs now. A little bit about OCPJP6 training, for which this, OCPJP6 exam, for which this training is all about. The total duration of exam is 150 minutes. The number of questions that you will be required to solve in it is 60, and passing score is 61%. Right. And regarding the exam topic, so the book that we recommend to anyone who is appearing for SCJP exam is this SCJP6 Study Guide by Kathy Sarah and Bert Bates. This is an excellent book to prepare for this exam, and this is the book that we also follow in our 4 days of training. Okay, and you can see we have actually divided the full SCJP syllabus into these 7 sections, and these 7 sections are totally based on this book, this SCJP6 Study Guide by Kathy Sarah and Bert Bates. Okay, and if you want to see which particular section is covered on which day of our training, you can see it on here on this slide. Right. So that's pretty much about the introduction part. Next, I will be actually taking up the topic of garbage collection. We will first of all discuss a bit of theory about it. Then I have a couple of interesting problems that you guys can actually see and solve it, and then we will discuss some approaches which you can actually use to solve those kind of problems. So anyone has any questions till now? Anyone having any questions till now? You can type your questions in this questions panel here. Right, great. So I can't see any questions, so let me actually begin with the topic of garbage collection itself. All right, so what exactly is garbage collection, why it is needed, and what are the things that you should actually keep in mind to actually help the garbage collector to reduce the heap memory. Okay, that is also very, very important. What are the things that you should keep in mind as a programmer so that you are actually helping the garbage collector rather than making its process difficult? Okay, because you can do 2 things. Either you can make its process much difficult, and that way it will not be able to do its job properly, or you can actually help it in doing its job. So let's see what exactly I mean by that. All right, so let me first of all begin with a little bit about memory management in Java. Okay, so whenever your JVM starts, so how do you start your JVM? You start your JVM by doing something like this, right? You say Java, right? And you give the name of the class that you want to run, which is actually containing the main method. So let's say it is com.test.sample. Okay, let's say com.test.sample is the class that you want to run, and you give it like this. What is going to happen? Your JVM is going to start. As soon as the JVM starts, it gets some memory from the operating system, right? Now, whatever memory it gets, it divides it into 2 sections. One section is called heap, and another section is actually called stack section. Okay. Now, why this is why there is the division of these 2 sections? The division is because any objects that you are going to create while running your program, right? Any objects that you are creating, they will be created in this heap section. Okay. And any method that you execute, right? So for example, we will always start with the main method, right? Any method that you execute, it will get a portion in this stack section, right? And the local variable of that method will be created in this stack section here. Okay. So actually, let me draw you a small picture here by just giving you a very simple and sample code here, in which we will just quickly make this diagram so that you are familiar with it. And after that, I'm going to discuss why garbage collection is needed, and I will illustrate it through this diagram itself. That way it will be much more clear. So let's say we have a class defined somewhere called test. Okay. Let's say this test class is having a main method inside it, public static void main method. Okay. What we are doing inside this main method is, okay, let me have another class as well. So let's say we have another class called employee. Okay. in this employee class, we are having an instance variable name and let's say private int ID. Okay, and then I have a constructor here for the employee class. Okay, which will just initialize these two instance variables. Anytime there are any questions in this code or anything, please feel free to just ask your questions through this questions panel here. Okay, do not hesitate at all. And finally, optionally, if you want, you can have a getter for this name and ID as well. Right? So let me just have a getter for ID. Okay, great. Now let's say in this main method what we are doing is we are creating first of all a very simple local variable called val, which will have 10 value. Then I am saying employee equal to new employee. Let's say name is John and ID is 2. Okay. Dhirendra, I can see your question. Don't worry about the definitions of heap and stack. They will become very clear when I make this diagram. Okay, let me just populate this diagram as I will show you line by line executing the main method. It will become clear from there. And let me just for completeness add another method here. Okay, just so that you guys don't feel that this approach is valid only for the main method, right? So let's say we have public static void m1 method. In this, what I am doing is I am taking an employee, and what I am doing is, do we have a setter for ID anywhere? No, let's add that. So guys, I'm just adding a setter for ID as well because I might need that. Okay, so I'm just adding a setter for ID as well here. All right, so okay, get ID, set ID is there. Name I do not want to change, so I'm just keeping it same here. All right, so let's say what we do in the M1 method is following e dot set ID is let's say 5, and after that what I'm doing is e equal to new employee. Name is, let's say, NPC, and ID is, let's say, 7. Okay, and after that what I am doing is, okay, e dot set ID 9, and that is it. And in the main method what I'm doing, I am just calling this with M1, passing E to this, and after that I'm saying here system dot out dot println, and I am saying print out E dot get ID. All right, so can anyone quickly tell me the output of this code? Should be simple, right? Not much is going on here. Right, great. I can see a lot of answers. So guys, let me begin, because this is just a sample code. Actual topic is garbage collection. This is just to get you started. Okay. Now let's see how this code will actually operate. Okay. So as I said, whenever the JVM starts, what is going to happen? These two sections are going to be created: heap and stack. Okay. Heap is meant for storing any objects that you are going to create. Stack is for local variables of individual methods that you are calling. So for example, here we will start with the main method, right? So what is going to happen? A main stack is going to be created, correct? Now, in the main method, you can see the first line is int val equal to 10, right? So a local variable called val will be created here. This local variable val is a primitive data type. As you can see, it is of type int. For primitive data type, their value is whatever you are trying to put here on the right hand side, which is 10, right? So we will say val is 10. After that, the next line is employee equal to new employee. This time there is this another local variable e. So this will get created here. E is an object reference, right? It is not a primitive data type. And always remember, Raj, we will actually see that. So method parameter and return values, where they are stored, they're actually stored here in this stack section only. Okay. Okay, so maybe you are getting confused that why I didn't store ARGS. So okay, that was wrong. Actually, I should have said that ARGS will be here in the main stack, but it will be null unless you are passing, of course, some command line arguments. Okay. In case you are not passing any command line arguments, it will be like this. ARGS will be there, but it will be having null value. Okay. Everything of the method will be stored in the stack section here only, corresponding to that method. Now, I said E will be created. E is an object reference, right? So let's say this is pointing to some 1000x location in the heap. Object reference always have their value as some memory address. Okay, they never have their value as the actual object. So let's say in the 1000x location in the heap, what we have is an employee object. What is this employee object having internally? Two instance variables, name and ID. So name will be created and ID will be created. And you can see from the constructor that we are calling, I'm setting name to John, ID to 2. So ID will be set as 2 here. And name again is an object reference, as you can see, right? John is a string and name is an object reference because of that. So name will be pointing to some other location in the heap where the actual string object is stored. And at 2000x location, what we are going to have? We are going to have a string object which is having John as the value. Parul, I can actually see your question. So can you do one thing? As soon as we are towards the end of the today's session, okay, once I have discussed all these problems, I can actually discuss this as well. You can just copy paste this thing again towards the end, and we can discuss that. Otherwise, we will digress from the current topic, right? I hope you understand, right? Okay, great. Anyway, so this will be the diagram till now. We will have this, and what are we doing further? You can see we are calling a method called M1, right? So a separate stack will be created for it, M1 stack. Okay. In this, you are taking E as the parameter, so E will be created here. What will be the value of this E? You can see we are passing something to it from the main method, right? So what is the value that it is going to get? Should be simple, right? Whatever E's value is in the main method, the same value will be passed to the E in the M1 method as well. Great, I can see a couple of answers. So E will actually get the value 1000x. Okay. It will be very specific. It will be 1000x only. You can see we are passing M1 here, right? We are passing E to the M1 method. And E in the main method is having 1000x. So this E in the M1 method also gets the value 1000x. Now when you say E.set ID 5, you're changing the ID value, but you are changing the ID value through this E here. So you will go to the 1000x location where this E is pointing to, and you will change the ID value there from 2 to 5. Okay? Any questions anybody is having till now? Alright. After that, you are saying E equal to new employee ABC, 7. So what is going to happen here? Again, a new employee object will be created because you are saying new employee. You are calling the employee constructor, which will create a new employee object in the heap. Oh, Tarun's question is set ID method is in a separate class. Will that have not its own stack. Yes, Tarun, we will actually need to create a stack for the set ID, but it's a very small method, right? So sometimes you can actually omit stacks for such short methods which are doing one very simple thing of setting an instance variable or something like that. Okay, you can skip something like that. Otherwise, you will have to create stack for each and every small method. Right, now, okay, we are creating a new employee object. So let's say at 3000x, I create an employee object. This time its name will be at some other location, let's say 4000x. You will have ID value will be 7. And at 4000x, you will have a string object where the name is what? ABC. Right, and what is going to happen? E in the M1 stack is now going to point to this, which is 3000x, because you said E equal to new employee, right? So E was pointing to 1000x in the M1 method, but now after this, it will point to 3000x. Please note that you will not change the E of the main stack at this point of time. E of the main stack was just used to initialize E of the M1 method, and after that, we don't have any relation between them whatsoever. If you change E to point to something else, that is not going to change E in the main method at all. It is still going to point to the same location where it was pointed. Local variable of a method can be changed only inside that method. That's why it is called local. Okay, Bhavin's question is, what if the name is same as John and ID is 7? Bhavin, that I think you are probably referring to the string pool, and that is why you actually asked this question. So if in case that was there, let me just quickly illustrate, but it's not related to the topic that we are discussing. So it's John, if you said something like this, what is actually going to happen? This 2000x string object John, which I created here, it will be actually in a pool. So string objects are normally created in a pool, and when you want to refer to a same string value which has been already created in the pool, in that case you will just get a reference to the already existing string object in the pool. Okay, you're not going to create a new object. Okay, but again, Bhavin, that's a separate discussion altogether, but I just gave you a high level picture of that. Okay, you're not going to create this 4000x string John in that case. You're just going to refer to the already existing John. Anyways, but we don't have such thing here, so this will be the scenario. And after that, I'm saying e.set id 9. So what is going to happen? You are going to set the id value of 9 of which employee object, 1000x or 3000x? Great, I can see answers. 3000x is absolutely correct because E in the M1 stack is right now pointing to 3000x. So you will go here and you will change this to 9. And after that, you can see M1 method is over. Always remember, as soon as a method is over, its stack is removed. So this will be removed from here. Okay. Now you're left with the main stack, and the last one is system.out.println e.getID. So I think you can easily guess the output of this line now. You just need to check where in the main stack E is pointing to and what is the ID value there. Guys, it will be 5, it will not be 9. You can see in the main method E is pointing to 1000x, and at 1000x you have ID value as 5, not 9. Okay. Now, I hope that is clear to everyone. Any questions so far? All right. So please notice one thing here. You have this object lying in the heap at 3000x location. Is anyone referring to it? Anyone referring to this 3000x? No, right? You created this object in the M1 method. You had a reference in the M1 method which was pointing to it, but that reference went away as soon as M1 method was over. Now you're just lying, this object is just lying in the heap, no one is pointing to it, and no one can ever point to it now. Because in Java you cannot say, make this E is this reference variable point to 3000x location in the heap. You cannot say that. You cannot explicitly specify a particular memory location by actual memory address. You cannot do that in Java, right? So no one can actually refer to this particular object now, both this 3000x and this 4000x string object. String objects are actually part of string pool, as I just mentioned. So they will actually, it is okay to actually have this 4000x string object lying here, because it may happen that in future you may want to refer to string ABC and you can be returned a reference from here, right? That can actually happen. So don't worry too much about this, but you do need to worry about the 3000x, right? So the thing is, what is going to happen at this stage is, or not necessary at this stage when heap is, let's say, quite full, there is a process called garbage collection, right, which is actually needed to remove these kind of objects, because you can see this object will otherwise always remain in the heap. There is no mechanism in Java, there is no mechanism through your code which you can trigger to actually delete this object. You cannot say free all the objects in your code. You cannot write any code like that. Okay, you cannot do that. So that is why unless garbage collector runs, this object will always remain in the heap. And you can imagine that there can be many such kind of objects which will be just lying in the heap and not getting deleted if garbage collector doesn't run, right? Just imagine you are calling, let's say, hundreds or thousands of methods, right? Each is creating, let's say, some internal object inside it, like, and just doing some processing, and after that the method is over. Method is over, but that object will be there in the heap, right? Somebody should be there to actually clean up that object from the heap. Otherwise, your heap will just incrementally get populated, and of course there is a limit on how many objects you can store there, right? Once that limit is crossed, you are going to get out of memory error, right? So definitely we need something like garbage collector, right? So what the garbage collector does is that whenever it is instructed by the JVM to run, it will scan each and every object in the heap, right? So for example, here we have 4 objects. In fact, you can actually say 2 objects, because technically these 2000x and 4000x are part of string pool, so they will never be garbage collected. They are not removed. So you can just assume that we have 2 objects right now, 1000x and 3000x. Garbage collector will see each one of them. It will see if there is any object to which you can reach from the stack section, right? If there is any object to which you can reach to the stack section, that means it is alive, right? And you should not delete it. Any other object, it will mark it as eligible for garbage collection and it will delete it. So in this case, for example, this 3000x will be found as eligible for garbage collection, right? Again, let me repeat. Technically, this 4000x is also eligible for garbage collection because no one is referring to it right now. But the thing is that strings are actually stored in something called string pool. String pool is basically used to cache the string values, right? And if you use the garbage collector to clear up the cache, then the whole purpose is defeated, right? So this string objects will not be deleted by the garbage collector, okay? You can assume that. And in the exam, you will not get any question in which you will have this kind of ambiguity like string object there, and you will be asked to tell how many objects are eligible for garbage collection, okay? But anyways, in this case, one object will be eligible for garbage collection and it will be deleted as soon as the garbage collector runs. Okay. Now, let me tell you some examples of bad code and good code, which actually helps the garbage collector, and bad code which actually doesn't help the garbage collector at all. Okay, we have one question from Hemant, and okay, we had one question from Radhika as well. So Radhika, I think you answered your own question, right? How many objects are eligible for garbage collection? 1, absolutely correct answer. Hemant's question is, at what instant the garbage collector will be called? So good question, Hemant. So garbage collector call cannot be actually predetermined. You can never predetermine when the garbage collector will be called. It's totally dependent upon the JVM's implementation. But what is the guarantee that you get from the JVM? The guarantee that you get is, before you get out of memory error, you can be sure that the garbage collector had definitely run. Okay. So for example, let me give you an example. So JVM can have something like threshold limit. For example, 70% threshold, meaning if the heap is 70% full, then run the garbage collector. 60% when the heap is, let's say, 60% full, then run the garbage collector, right? there can be different scheduling algorithms for the garbage collector, but as a programmer, you don't need to worry about it because those algorithms are going to change from JVM to JVM. Okay, Ritvik's question is, okay, first of all, Tejas' question, can we configure threshold limit? No, Tejas, you cannot actually do that. Threshold limit is just one type of scenario that I have told. There can be many other garbage collection algorithms as well. So there can be some time limit algorithms as well. So if these many seconds are passed, then the garbage collector, right? There can be something which is using combination of these threshold limit plus time limit or anything like that, right? So there can be some complicated garbage collections, and you actually don't need to worry because you are getting the guarantee that before the garbage collector is run, before you get the out of memory error, the garbage collector would have definitely run. Jagdish question is, garbage collector program is internally running for regular periodic intervals of time. Jagdish, you cannot actually be sure about that. As I said, the scheduling algorithm of garbage collector is totally dependent upon the JVM's implementation. Okay. And for example, IBM's JVM might be having a different scheduling algorithm for garbage collector than the Sun's JVM, right? And again, you don't know where your code will be running, so you should not assume any particular algorithm at all. And you don't need to worry about that. Ritvik's question is, how does GC check objects that are not being referred from stack? So Ritvik, that algorithm is actually very simple, okay? In fact, that is what we are going to do when we actually solve a couple of problems on our own. We will actually wear the garbage collector's hat, and we will see how many objects are actually eligible for garbage collection, right? So the same thing can be used by garbage collector as well. Mauricio's question is, garbage collector do not clean 4000x. So no, garbage collector will actually not clean 4000x. Mauricio, the reason is that this is a string object, and string objects are created in something called string pool, and string pool is not subjected to garbage collection. Otherwise, if it was any other object apart from string, it would have been eligible for garbage collection. Tarun's question is, how are strings cleaned? So Tarun, the string pool actually has a limit on how many strings you can actually create inside it. Once that limit is reached, the other string objects will be created in the normal section of the heap. Okay, and they will be obviously eligible for garbage collection. So that is why I said that you will not get any question in the exam which will ask you whether this string object is eligible for garbage collection or not. Jagdish question is, like M1 stack got removed after exiting the M1 method, is the same thing going to happen for the main method as well? Sorry, for the main stack as well. Jagdish, yes, absolutely correct. But you can see that as soon as the main stack is over, the JVM will be finished as well, right? Because that is what JVM was supposed to do, to run the main method. As soon as the main method is over, why do you need why do you need heap? Why do you need stack? You don't need these, right? Because JVM's job is over. So JVM process will be finished, all the memory what it got will be taken away. So there will be nothing like stack and nothing like heap after the main method is over. Alright guys, let me actually just continue with the topics that problems, because otherwise we will run out of time. I will keep answering your questions as I'm seeing the questions coming up here. Just in case you feel your question hasn't been answered, just feel free to retype it in the questions panel. Okay, so guys, here is the question that we want to solve, and we have a main method here and few lines of code in which I am creating an object of sample, calling this modify. Again, the question is, once you reach this line here, which is commented out, how many objects do you think will be eligible for garbage collection? So guys, have a couple of minutes to solve this question and let me know your answers. Let me know if the question is not clear. Alright, I can see a lot of answers. So guys, should I begin or anybody needs more time? Alright guys, so let me actually go ahead and solve this question. So alright, so what we will have is we will have a heap here. Again, let me just draw the heap stack here only. Okay, heap and stack, and the stack for main method will be created. First of all, what are we going to have in the main stack? First of all, a local variable called s1. Corresponding to it, we need to create an object in the heap at 1000x. So let's say at 1000x we create a sample object. This sample object is going to have an instance variable inside it called I1, right? So I1 will be created here. I1 will, let's say, point to 2000x location. Please note that this I1 is of type integer and not int, and hence it is not a primitive type, it is an object reference. So at 2000x I am going to have an integer object which will internally have this value 400. Don't need to worry about it. But anyways, just to make the picture complete, I need to write 400 here. Okay, that is the scenario. Then you say sample s2 equal to new sample. So just the same thing will be repeated. S2 will be created here. Let's say at 3000x. And 3000x, you are going to create another sample object. You will have I1 reference variable there as well, pointing to, let's say, 4000x. At 4000x, you are going to have an integer object having the value again 400. After that, you are calling the modify method, passing s2 as the parameter. So let's say we have this modify stack here. Modify stack will have a local variable inside it called s. Can people guess what will be the value of s as soon as we enter this modify method? You need to check what are we passing to the modify method from the main method. That is it. Right, so we are passing S2, right? So S2 is having 3000x in the main stack. So 3000x is what this S in the modify method gets. After that, you are saying s.I1 equal to new integer 9, right? So what is going to happen? You're going to create a new integer object in the heap, right? Because you are saying new integer 9, right? This will always lead to creation of a new object. So let's say at 5000x, I create a new integer object having the value 9. Okay, and what did I say? I said s.I1 equal to new integer 9. So you need to go to the location where s is pointing to, which is 3000x, and you need to change this I1 here, right? So what will be the new value of this I1? It will be 5000x, right? So guys, those who are saying 9, they are partially correct, but ideally you should say 5000x because I1 is an object reference. And it will have its value as some memory address, right? And not the actual int value 9. Anyway, so this will be the scenario. I hope this is clear to everyone. After that, you are saying s equal to new sample. So this is going to create a new sample object in the heap, right? You're calling the sample constructor. So let's say you create a sample object in the heap. It will have an instance variable I1. Let's say it is pointing to 7000x. At 7000x, you are going to have an integer object here, which will again have the initial value 400. And our s in the modify method, which was pointing to 3000x, will now point to which location? (6000x), right? Not 7000x. At 7000, we have an integer object. We created the sample object at 6000. So we will refer to 6000 object from here. Then you are saying s.i1 equal to new integer 20. So again, you need to create a new integer object. So you do that, having the value 20 here. Okay. And you said s.i1 equal to new integer 20. So you need to go to the location where s is pointing to, which is 6000, and you need to change this i1, right? You need to change this i1 and you need to make it 8000x. Okay. After that, you are saying s equal to null. So s was pointing to 6000x. Now it will not point to it. All right, it will point to null. After that, you can see you are saying return s. So s value will be returned. And you can see we do have a variable in the main stack which is catching the return value from modify. So what will be the value of s3 in the main stack when modify method returns? Great, it will be null, right? And as soon as modify method is over, you can safely remove its stack from there as well. As I said, as soon as a method is over, just remove its stack. Okay, this last line in the main method is s1 equal to null. So s1 was 1000x, now it will be null. That is it. Your diagram is complete. You are at the stage where now you need to guess how many objects will be eligible for garbage collection if the garbage collector runs now. So first question, how many objects we created in total? 8, right? You can see 8 locations in the heap full, so 8 objects were created. Now, we need to guess how many objects will be eligible for garbage collection, right? So we will actually do the reverse. We will try to find out how many objects are not eligible for garbage collection. Okay? Because it seems that that will be much easier than finding out which objects are eligible for garbage collection, right? Let me show you how. So what you need to do to find out which objects are not eligible for garbage collection, you just need to go to the stack section, okay, and see what are the locations which you can reach from the stack section in the heap. You can reach 3000x, as you can see here. So this 3000x is not eligible for garbage collection, right? Clear about this, everyone? Any other location we can reach from main stack? So as quite a few people have written, absolutely correct. We can reach 5000x as well, right? So we cannot reach that location directly, but you can reach it through S2, right? All you need to say is S2 dot I1, right? As soon as you say S2 dot I1, boom, you are at 5000x, right? Clear about this, everyone? You just need to say S2 dot I1. And at S2's I1 you have 5000x, right? So you will reach at this 5000x, correct? So this is also not eligible for garbage collection. Any other location you can reach? No, there is no other location you can reach. So 8 minus 2, that's 6 objects are eligible for garbage collection. Okay? So I guess there was one question asked, which was how will garbage collector determine which objects are eligible for garbage collection? So this seems to be a perfectly valid way to determine, because if we can determine it, then the same thing can be programmed in the garbage collector as well, right? Go to the stack section, see where you can reach, and then just mark those objects as eligible for garbage collection which you cannot reach, right? Okay. Any questions anybody is having from here? Yes, so Tarun's question is, as a good practice, we should assign null to the objects we have created. So Tarun, yes, absolutely. So let me give you a very quick and small example. You will not need to define null explicitly sometimes, but sometimes it might be needed. So for example, let's say you have a method called public void process images, okay? in this method, what you are doing is you are having some image processing routine, and you can imagine that the images that you are going to process are huge, right? So you have something like this: image I1 equal to new image, and you give some path here, okay? Some path which is from the file system somewhere, right? And some images there, maybe let's say 1.jpg. Okay, you're just loading it, creating some kind of image object. After that, you are doing some processing here, okay? And after that, you just moved to second image object. So now you basically say something like this. You have to process, let's say, 3 images, and you say something like this: image I2 and then image I3, and this is loading image 2 and image 3, right? And doing processing over whatever images have been loaded. Now let's say when you try to do this for the 4th image, you get an out of memory error. So if you try to do this, let's say you get out of memory error. Can anyone tell me why you are getting out of memory error at this line? And what can you do to fix this? Right, so in fact I can see 2 answers and both refer to perfectly valid solution. So Alexander and Tarun, you guys have written correct answers, so definitely you can do. And the thing that you can actually do is, there are 2 solutions. One is, as soon as you are done with object, so you, for example, you are done with this particular image object, just say I1 equal to null, okay? Otherwise, what is going to happen is, okay, let me actually show you what is happening right now, okay? Why you are getting that error. So you have heap and you have stack section. In the stack section of this process images method, you create I1. Let's say I1 points to 1000x. At 1000x, you have this huge image object. Then you do some processing. Then you say I2. You make it point to 2000x. At 2000x, again you have an image object which is again huge. And then you say I3. And you say 3000x. Again, this is a huge object. Now, when you are trying to create this I4, right, what is going to happen? The JVM is going to see that, okay, heap is very much full. So let me run the garbage collector. Right? As I said before, it will throw out of memory error. It will try cleaning up with garbage collector. Right? It will run the garbage collector. Garbage collector will see that all these objects are still being used, still being referred. So it cannot delete any of them. It will just return. And now the JVM will see that, okay, the heap is still very critically full, so I cannot do anything, and let me throw out of memory error. Okay. Now, if you say something like this here, right, as I think Tarun or Alexander or some other people suggested, you can say I1 equal to null. And as soon as you are done with an object, you just nullify the reference so that that reference doesn't point to that object anymore, right? If you do this, what is going to happen? I1, as soon as it is done, it will point to null. I2, as soon as it is done, it will point to null. I3, as soon as it is done, it will point to null. Now, if the garbage collector runs, right, still the heap is overpopulated, as you can see, right? The JVM is going to run the garbage collector. As soon as it sees that, okay, the garbage collector runs, it will see that no one is being referred from anywhere. So it will just clean this up. And now heap is again empty. So at 1000x, you can actually create a new image object, which can be given to I4. And that is it. Processing can be done now. Another solution is, instead of nullifying the references like this, just reuse the reference. So instead of saying image I2 equal to new image, just say I1 equal to new image here. Right? Always use this common local variable that you used for the first one. Because in this case, what is going to happen? This is in fact a better solution. The reason is that here you are always going to have I1. Initially it is going to point to 1000x. After that, once you are done with this first image, there will be this 2000x image object, right? Here I1 will be now made to point to this. Then you will create something at 3000x, and again you will make I1 point to that. Okay. Now finally, when you are trying to do for the fourth one, what is going to happen? JVM is going to see that, okay, heap is full, let me run the garbage collector, and now you can see the first two can be removed, right? Not the third one, because I1 is still pointing to it. But if you remove the first two, still you get the space for creating the fourth image object, right? So again, both solutions are fine. You can use either one of them. Okay. Raj, I think you can probably take over. I can keep on answering the questions in the meantime.
Thank you for watching this video. You were watching a short snippet of the full-length videos. Please visit our website www.whizlabs.com to view the full videos and take a sample practice test.